Hi everyone, it's me again, Paulina. In the past video, I spoke to you all about 3 applications of the Mechanomutable Asphalt materials in roads. So in this video, I'm going to talk to you a little bit more in detail about the first application. The Mechanomutable Asphalt materials has improved materials for roads. Taking a look inside the microstructure of these materials, we can produce them at 2 levels: the binder scale and the mortar or mixture scale. In the first case, the production of the mechanomutable asphalt binders could be possible by their modification with powder steel slag, powder magnetite, powder carbonyl iron, graphene, graphite, carbon black, and carbon nanotubes. I would like to start talking about the mechanism of functioning behind these materials. For this, I'm going to make reference to a study done at the University of Granada before my PhD, where carbonyl iron particles were used. When a magnetic field is applied on a mechanomutable asphalt binder, their magnetically responsive materials suspended will tend to align with it, and 2 situations can occur. 1. If the material is at low temperature, the movement of the magnetically responsive materials will generate an internal stress field which improves the dynamic modulus of the binder. And 2. If the material is at high temperature, the magnetically responsive materials will create an internal structure which also improves the mechanical capacities of the binder. So, the first part of my project was to scale this to the mortar scale. For the production of mechanomutable mortars or mixtures, it's possible to use carbon fibers, steel wood, magnetite, steel slag, steel fibers, industrially produced or obtained from the end-of-life vehicle tires, and ferrite filler. So, also thinking in promoting the recycling practices, we decided to select the steel fibers obtained from the end-of-life vehicle tires. From this study, we found that the change in the modulus reached at the mortar scale is lower than the one reached at the binder scale. The increase in the dynamic modulus by the activation in the magnetic fields depends on the intensity of the magnetic field applied and the content of metallic fibers used. At 45 centigrades, which represent typical temperatures at summer in Spain, we reached higher increments in the dynamic modulus than at 25 centigrades, which can be a typical temperature for seasons near the summer. But the higher rates of increase of modulus are produced at 25 centigrades. Thank you very much. If you want to have more information about this or any other project of Smarty, don't forget to follow us in our websites and social network channels. Bye!